Hi friends, in this video we can see the next example 4 of first unit real numbers, the CBSE 10th maths. Okay, here the fourth example is a statement problem. What it states is a sweet seller has 420 kaju burfis and 130 badam burfis. She wants to stack them in such a way that each stack has the same number. So stack should have the same number and they take up the least area of the tray. So it should take the least area of the tray. What is the number that can be placed in each stack for this purpose? So in order that it occupies least area, it should have a maximum possible outcome, that is maximum value that is common for both these two burfis. So we have to find the highest common factor. So for example 4, we have to find the HCF of both 420 and 130. Let's have this one for rough work. We know that the lemma states as A is equal to BQ plus R. R lies between 0 and B. So the larger number is 420 is A and the smaller one is 130 into Q plus R. We have to find Q and R. So 420 is to be divided by 130 and it is approximately 3 times, it comes to 390 and the remaining is 30. So R and Q. So we can rewrite the expression as 420 is equal to 330 into 3 plus 30. Again we have to repeat the same, is equal to 30 into, it comes to 4 times, that is 120 and the remainder would be 10. So again we have to repeat the same, 30 is equal to 10 into 3 times and the remainder is 0. Here we have arrived at 0. So this is our remainder and this is our HCF. So each stack should have 10 burfis. So this is our final answer. We have completed example 4. Then we will move on to next exercise problems. Here let us start with exercise. So the first problem is we have to find HCF of 135 and 225. We can take this problem and solve this now. Okay. So the first problem in the first subdivision, HCF of 135 and 225. So let us have a rough work. So the lemma is A is equal to BQ plus R. R lies between 0 and B. So A is the larger number, 225 is equal to 135 into Q plus R. So 225 divided by 135 is 1 time 135 and the remainder is 90. So this is our R and this is our Q. So 225 is equal to 135 into 9. 1 135 in plus 90. So again we have to repeat the same. 135 is equal to 90 into, again it's one time and the remainder is 45. Okay, then for 90 is equal to 45 into 2 times would be 90 and the remainder is 0. We have arrived at the remainder 0 and this is our HCF. So the HCF of these two numbers is 45. So 45 is the answer. In the same fashion we can perform for the next two subdivisions. Next we will move on to the next problem, problem 2. Exercise 1.1, the second problem. For the second problem, what it has been asked is, show that any positive odd integer is of the form 6q plus 1, 6q plus 3 and 6q plus 5. Here the b value is given to be 6. So r can have values because r is less than or equal to 0, less than b. So r can have values right from 0 to 6. So 1, 2, 3, 4 and 5. These values. It should be less than 6. So for these values of r, we can write a is equal to b is 6. So 6q plus 0. Next one is 6q plus 1, 6q plus 2, 6q plus 3, 6q plus 4, 6q plus 5. So these are all the possible values. For this, 6 being an even number, the result would be even. For example, for instance, if you take q to be 1, for this you will have the value as 6. For this you will have the value to be 7, 8, 9, 10 and 11. So this is even, this is odd, this is even, this is odd, this is even and the other one is odd. So what the question is, positive odd integers. So odd integers would be plus 1, plus 3 and plus 5. So for any value of q, if a is to be an odd one, it can have the values such that it has 6q plus 1, 6q plus 3 and 6q plus 5. So this has been proved hence. Okay. For any instance of q, you can have value of q to be 10. Again it's in a similar fashion. Okay. It will have 60, 70, 60, 61. In a similar fashion it moves. Okay. So being b even and plus 0 would be your even integer value. Okay. So this is the proof. So we are done with the second problem and we can move on to the next problem. So 1 and 2 completed. We are moving to the third problem of exercise. Exercise 1.1, problem 3. It is again a statement type of problem. Here an army contingent of 616 members is to march behind an army band of 32 members. So we have to arrange the army contingent behind the army band. So they should have equal number of columns so that it looks uniform. So the band looks like this. Behind that the army has to march like this. So this would be the marching system. So here it should have uniform number of columns. That is the main basic criteria. So this is our rough work. Okay. For this, what they are asking is the two groups are to march in the same number of columns. What is the maximum number of columns? Maximum number means the highest common number which the columns can accommodate, that is HCF. So we have to calculate the HCF of 6, 16 and 32. So we know the dilemma is A is equal to BQ plus R. R ranges between 0 and B. So A is 616 is equal to 32 into Q plus R. So we can calculate this Q and R. 616 divided by 32 is approximately 19 times. 32 into 19 is 18. And again 32. 801 is 608. So substituting 608 here, we'll get 8 as the remainder. This is our remainder and this is our quotient. So 616 is equal to 32 into 19 plus 8. Again I am repeating, 32 is equal to 8 into how many times? 4 times. Plus the remainder is 0. So this is our remainder and this is our HCF. So maximum number of columns is equal to 8. This is our answer. So the answer for this problem is 8. So right now we have completed 3 of our exercise problems. The other 2 problems are of similar fashion, so we can proceed it in the same manner. So as of now, thank you. Keep watching for other videos.